Welcome to Water Supply and Wastewater Engineering class. So today we'll be discussing lecture number 16 and we'll be starting the new unit, that is the second part of our course, that is the wastewater engineering part. And the unit 6 will be discussing a municipal water, wastewater quantity and quality estimation. So this is not and it is basically estimation. Yeah, so the lecture number 16 will be discussing about the wastewater quality and the quantity estimation. So now in this slide, we'll be discussing about the wastewater quantity estimation. So if you recall in this course, what we have discussed at the beginning, whether the water supply part, we have distributed the clean water to the industry as well as the household entire cities. We have distributed clean water. Now this clean water, the people of the city or the industry also will consume this water, this clean water, and they will produce the wastewater. So now, as a civil engineer, our job will be to collect those wastewater which is produced by the industry as well as the individuals, and then we have to treat it before we dispose of into the water stream. So this process in the second half we'll be discussing how to collect the wastewater and how to design the different units for for the purification of wastewater, and ultimately it is disposed of to the water stream or any dumping ground anywhere, so depending on again areas. So in this lecture basically we'll be discussing about the quantity estimation, very similar to what we have discussed at the beginning, lecture number 1 and 2, where we have discussed about the quantity water supply estimation. Okay, so before we treat or before we design the different treatment plant, first we have to understand how much total quantity of water, wastewater is produced by the city as well as the industries also nearby the city, and that much quantity of water has to be treated every day, wastewater, and then we have to dispose of. So the wastewater quantity estimation, the flow of sanitary sewage alone in the absence of stormwater, right? During the summer time, during the monsoon time, basically, when the rain happens, the rainwater also comes to the water, to our water treatment plant, to our sewage water along with the sewage water. So apart from that, monsoon water also in general, there is a dry water weather flow. That is how much that we are first identifying. The quantity of wastewater equal to per capita sewage contributed per day population, right? Per day means each person, how much wastewater is produced by each person. Similarly, what we have done is for the water supply distribution also, we have calculated each person approximately how much water one person consumes in a day. So similarly, per capita per sewage contribution per day multiplied by, if you multiply the total population of the city, this will give you the total quantity of wastewater generated each day by the city. So the sanitary sewage is mostly spent water of the community draining into the sewage system. So whatever we distribute it during the water supply part, we distribute the clean water to the to the household or the industry. So out of total wastewater, clean water, approximately 80% of the this water supply what we have done it, 80% will come back as a wastewater in our sewer pipes. So it can, so we can expect that whatever clean water we have distributed to the city, so approximately 80% of that should be coming into our wastewater system. Why? Because 20% maybe loss of evaporation, or maybe seepage to the ground, or maybe any leakage happening in the pipe. So these are the different ways how the water will be evaporated, or loss will be happening. But approximately 80% will again come back to the sewer system. So we can, that is the initial guess, a good guess we can estimate initially, that approximately whatever we distributed, those 80% can be again coming as a wastewater treatment. So similarly, what we have done earlier, that is the fluctuation also will be happening in the wastewater generation also. Similarly, what we have seen, the water supply also, water demand also, there is fluctuation, right? In the morning time, the water demand was more. Even in the evening time, water demand was more. In the middle time or in the night time, water demand is very less. So there is the fluctuation in the water supply, right? The similar thing happens in the fluctuation in the dry weather flow also. So the weather, the wastewater also is not produced, constant rate in across the day or across the month or across the year. So it will have a variation also. Since the dry water flow depends on the quantity of water used, right? As there is fluctuation in the rate of water consumption, there is the fluctuation in the dry, weather flow also. So in general, you can assume that the maximum daily flow that could be 2 into multiply the average daily flow. So what is the average flow? You observe it maybe for one day, how much water is coming, like that for multiple days we can take the survey and what is the average. So that average, if you multiply it by 2, then approximately we'll get that is the maximum daily flow. Means during the morning time, when the water demand is also more, that time when everyone takes the bath, they will wash the clothes and all. So the morning time, the maximum daily flow will be there. So that may be 2 into what is the average daily flow. Similarly, the minimum thing, that is a night time, you can consider it as a two-third of average daily flow. So average daily flow already is computed. So based on the two-third, that is approximately 66%, maybe in the minimum daily flow, means the evening time or night time, basically that is the minimum flow we can consider for the estimation of the total wastewater quantity. So another very much important, now we understand that how we can collect the water from the household, right? So household, each person, how much they are contributing as a wastewater, that will be multiplied by the total population. We get approximately the what is the total wastewater generated by the city. But what about the industry? So industries will produce large quantity of wastewater. So that how we can quantify. So that we are quantifying it with BOD. One very important term is BOD. So BOD is, we call it biological oxygen, biochemical oxygen demand, BOD 5. I will explain in details what is the meaning of 5. So the standard BOD of say, domestic sewage per person per day multiplied by the population equivalent. So the industry, although the people won't stay here, right? The industry, because of production purpose or different processes in the industry, wastewater is produced. So those wastewater will convert it into the population equivalent. So that is equivalent to how much population? Okay, that is how we are converting the waste from the industry, and we quantify it. So the population equivalent is a parameter used in conversion of contribution of the waste from the industrial establishment for accepting into the sanitary sewer system. So the strength of the industrial sewage is thus retained. So the strength means the some industry will produce less toxic sewage, whereas some industry will produce very high toxic sewage. So that how much is the strength of the industrial sewage, that can be calculated using the BOD term. So BOD is nothing but biochemical oxygen demand. We'll be discussing this parameter in details in the upcoming lectures also. So in the last slide, we have seen how we can compute the total wastewater estimation in the entire city by simply multiplying it with the each per capita, how much waste is produced multiplied by the population. Now similarly, here in this slide we have seen how we can convert the industrial waste into the normal standard population equivalent, and then we can do the estimation also. So now, as we have done similar thing here also, the process will be very similar what we have done in the water supply topic. So here also, each because here we are designing the wastewater treatment plant. So similarly here also we have to design it for the design period. So what is design period? So design period is basically the future period up to which the wastewater treatment plant should be workable. Similar thing what we have done it in the water supply part also. So this quantity should be worked out due to the provision for the estimation of the requirement for the future, right? So today, whatever wastewater plant today we are designing, that wastewater plant should be serviceable for next 20 years or 30 years also. So for that we have to forecast the population. Similar thing what we have did, same formula, same thing we will be employing here also for the population forecasting. Because whatever where the wastewater treatment plant today we are designing, that same plant should be serviceable for next 20 or 30 years also. So in this 30-40 years, the population of the city also will increase, right? So that we have seen how what is the population forecasting, what are the different methods. So same formula, same thing again will be using in this calculation also. And the design period, we understand that is the future provision for which what the water supply scheme is known as the design period. Means after next 20 years or 30 years, for that we are designing the entire treatment plan, that we call it is the design period. So it is suggested that the construction of sewer treatment plant may be carried out in phase, right? At the initial design, maybe 5 to 10 years. So because the cost of construction will be huge here, because here the water quality is very bad, right? Compared to earlier what we have done, the water supply. So in the water supply part, basically we are collecting comparatively clean water, right? And then we are treating it and we are distributing to the household. But in this wastewater treatment plant, basically we are collecting the wastewater, right? That means the quality of water is very bad here. So the treatment process also will be very much, costly. So that's why the entire treatment design means we will do it, partly the entire, treatment plant construction. So initially we design it for the 5 to 10 years, then gradually, we increase the treatment plan. So the initially we can 5 to 10 years we can start designing, and then the remaining part will be doing it in a phase manner. So the design period of, year estimation is based on following factors. Basically, we can choose what could be the design period for the wastewater treatment plant. So the useful life of the component, right? So each part, like the wastewater we are collecting through the pipes. So what is the design period of pipe? Means each pipe maybe, up to, maybe each pipe every 5 years you have to change the entire pipe system because of, damage happened because of corrosion and many things happening in the entire system. So the component of the water system, water wastewater treatment plant, that is how much is the life of each component, and also where tier these things will be happening, right? So that also has to be considered. So depending on that you can choose what is the design period. Similarly, expandability aspect. So like in future, the city, how much growth and all is happening, so how much industry will be coming up in future, that also depends, the design period estimation. Anticipated rate of growth of population, industry, including industrial, commercial development, migration, immigration, all these things has to be considered. Similar thing what we have done it earlier also in the water supply part. Then availability of resource, and obviously the primary, performance of the system during the initial period. So initial period, how much it is performing, because here the treatment process will be very much costly and it will be very much sophisticated what a wastewater treatment will be doing, because here the quality of water is very bad compared to earlier what we have done it for the water supply. So now before we design the wastewater treatment plant, first we have to understand what are the characteristics of wastewater treatment plant. Similar thing what we have done for the water supply also. We have understood what are the characteristics of water, right? Raw water. Similarly here we are understanding what are the characteristics of wastewater. So once we know what is the characteristics of each, wastewater, so based on that we can design the, water treatment plant. So some unit will be, purifying the nitrogen content which is present in the wastewater. Some unit will be, designed for, purifying the phosphorus, chloride, like that each unit will be there, right, to purify some quantity of some pollution from the wastewater. So before we design, basically first we'll understand what are the characteristics. So first one is the temperature. So whenever we get wastewater, first we check what is the temperature of the wastewater. So if the temperature is more, that means you can understand the quality of wastewater is very bad. Means the more quantity of, the pollution is present in the water. The next is pH. So pH also you can understand. So if by understanding the pH value of water, we can estimate that with the quality of wastewater how much it is. Similarly, color and odor. If the color is very much, brownish color of the wastewater, you will find that means the pollution level is very high. Similarly, odor means even if very bad smell is coming, then again the pollution is very high in the water. Similarly, carbonious substances are present in the water: nitrogen, phosphorus, chloride, total and suspended solids, toxic metals and compounds. So all these parameters basically will be finding out from the wastewater, and then, we design the wastewater treatment plan. So based on, some quantities may be high, some quantities may be less. So which one is less? So that part of treatment may not be required, but those quantities are very high, that definitely treatment is required before we dispose of the wastewater into the water stream. So now in the next slides, basically we'll be looking into each parameters in details, and we'll be understanding how it impacts the pollution level in the wastewater. So the first characteristics of wastewater is the temperature. So the as observation of temperature in the swage is useful in indicating the solubility of oxygen, which affects the oxygen transfer capacity of in aeration equipment, right? So because as we have seen earlier also, the oxygen is, very good parameter which by which we can tell that the quality of population how much it is. So if the microorganism or the pollution level present in the water is more, then what will happen? Always the chemical reactions will be happening inside the wastewater, and the temperature also will be increasing gradually. So in the wastewater, basically the temperature will be slightly higher than what we have seen in the water supply. Okay, because here in the wastewater, that chemical process will be running continuously, that the virus bacteria will be, reproducing. So because of that, the heat will be generated. right? Even for the different chemical reaction also takes place. For that also, this temperature will be increased in the water. So based on measuring the temperature, we can say that how much pollution level is present in the water. Now the next parameter is next characteristics of wastewater is the pH. So the pH of a fresh domestic water is slightly more than the water supply. So whatever we have supplied it during the water supply phase. So in this in the wastewater, the pH will be little slightly or more. Why? Again, this is also depends. Sometimes if we are collecting the water from the septic condition, or then in that case the pH will be low. Okay, depending on maybe some industrial wastes are coming into the wastewater. So in that case also pH value may be lower or higher. But by looking into the pH value of the wastewater, we can approximately guess the quality of wastewater. Okay, so this is one more indication that is pH value of a water. Now the next parameter is the color and the odor. So that is by looking itself we can say that what is the quality of water, whether it is bad or it is good. Because if the color is very much brownish, if you see in the wastewater, that means the pollution level is very high. Similarly, the odor means the smell, right? So if the wastewater has more smell, then obviously the pollution is more in the wastewater. So in the fresh domestic sewage is slightly soapy and earthy odor, and the cloudy appearance will be there depending on its concentration. So more pollution means the more cloudy appearance you will be finding in the water. So with passage of time, the sphere becomes more darken in color, because more and more reaction will be happening inside the water supply in the wastewater, and also the odor also will increase gradually. So based on these two parameters, you can identify what is the quality of wastewater. So now the next important characteristics of wastewater is the carbonaceous constitution. So the carbonaceous constitution are measured by BOD, COD, and TOC. What is BOD? BOD is biochemical oxygen demand. COD is the chemical oxygen demand, and the TOC is the total organic carbon. So all these things will be seen. So based on this quantity, again we can classify the wastewater, how much it is, whether it is good quality or it is bad quality. So while the BOD is the common parameter, basically always we perform the BOD in the wastewater. So BOD will give us an indication that how much pollution are present in the water. So the BOD experiment is nothing but we are finding out how much oxygen demand is there in the water. So for example, in a water, basically, if in a wastewater, if the more pollution is there, means what? So more organic matter will be there present in the water. So those organic matter will decompose, right? This will react with the oxygen present in the water, and gradually it will uh, convert some from one form to another form. So so based on the oxygen demand, if oxygen demand in a particular water is very high, that means you understand that the pollution level is also very high in the wastewater, because oxygen demand will tell you, if the oxygen demand is very high means what? So more number of microorganisms are present in the water, more number of organic matters are present in the water. That's why the oxygen demand is also more. So this is very much one important parameter by which we can tell that what is the pollution level present in the water. Now the next is chemical oxygen demand. So here in the wastewater, different types of chemicals will be present in the water. Those will react with the oxygen present in the water, in the wastewater. So again, for the chemical reaction takes place, how much oxygen is required. Based on that oxygen demand, we can identify that how much pollutions are present in the water. Then lastly, the total organic carbon. So total organic carbon analysis how allows the total soluble carbon analysis to be made directly on the aqueous sample. So in many cases, TOC means total organic carbon can be correlated with the COD and occasionally with the BOD, right? So if more number of organic carbon is present in the water, then the more number of reaction will be taking place. That's why the more oxygen demand will be there, right? So the total organic carbon also can give estimation that how much is the pollution level in the wastewater. So depending on which quantity is more, we have to design the water treatment plant accordingly. So now the next important characteristics we can find it out in the wastewater is the nitrogenous constituents. So the principal nitrogenous compound that is in the domestic sphere are protein or the amines or amino acid or urea, right? From there, basically nitrogen content will be coming into the wastewater. So nitrogen may be present in the different forms. It may not be directly available. Nitrogen may not be there, but in form of organic nitrogen, or some other ammonium nitrogen, nitrate nitrogen, nitrate. So there are different nitrite nitrogen. So different forms, by different forms, nitrogen may be present in the wastewater, so depending on the again the sewage condition. So again, some factories also produce a large quantity of nitrogenous that is nitrogenous pollutants. So we have to identify how much nitrogen constitutions are present in the water, and also in which form nitrogen is present in the water. So based on that, we can design the water treatment and wastewater treatment plant. Now the next characteristics of wastewater is the phosphorus content. So in the municipal wastewater contains phosphorus in three different spots. Again, similar to what we have seen in the last slide also. So here also phosphorus also may be in different forms. Directly, last slide we have seen the nitrogen, right? So nitrogen also will be present in the different forms. Similarly, phosphorus also representing in the different forms. You can see. So while treating the wastewater biologically, bacteria during this growth process, like, so basically if the phosphorus content is more in the water, more in the wastewater, then biologically biological treatment has to be performed to remove this phosphorus content present in the water. So in the biological wastewater treatment plant is the only by which the phosphorus is removed, right? Basically only biological wastewater treatment you have to do it to remove the phosphorus content present in the water. Next is the chloride. So as we have seen, chloride or chlorine is basically we have used in the water supply also to treat it for the disinfection, to kill those viruses and bacteria present in the water. We have used chlorine or the chloride present in the water. So some percentage of chlorine and chloride is good for for the water. But again, if it increases more than 100 milligram per liter, again the chloride is not good for the wastewater. So the IS Indian standard recommended value is 250 to 1000 milligram per liter. So if the chloride content is in this range, then it's fine. Otherwise, we have to treat it for the purification purpose. So the chloride ion will be present in combination with one or more cations, right? For with the calcium or magnesium, iron, or with sodium, basically it combines, and in chloride form it will be present. So the chloride of these minerals are present in water because of high solubility in water, right? For example, human also we consumes like salt, right? Salt is composed of sodium chloride, NaCl. So we are consuming NaCl, so that NaCl or chloride basically is coming into the wastewater also. So uh, um, this that's how basically chloride content is also coming into the water. And if the quantity is more than, if the chloride percentage is more than 1000 milligram per liter, again we have to treat the water, and we have to remove the chloride content from the water. So the next important parameter, that is the solids. So we have seen how we have removed the solid from the water during the water supply treatment. So here also we'll be seeing how much solid present in the wastewater. So we call it total solid, which includes both suspended solid as well as the dissolved solid which is present in the water. Okay, so the suspended solids basically will do it through this filtration, what we have done it earlier in the water supply. Also we will use sedimentation tanks, and the set level particles will be simply settled down at the bottom, so that's fine. So the suspended solids, or maybe we can add some coagulants also, and we can remove the solids present and suspended solids from the present from the water. But sometimes but the dissolved solids are very difficult to remove from the water. In that case, what we have to do is we have to filter, or we have to evaporate the water which is present in the water, and then basically the entire water treatment has to be dry. So the dissolved solids basically we have to evaporate, or through dry up, basically all the water will be evaporated, and the remaining solids will be collected from there. So like that, basically we can segregate the solids present in the water, in the wastewater. Now, the last compound or the characteristics of wastewater is the toxic metal and the compound. So in the water, in the wastewater, basically many toxic metals also will be present in the water, like such heavy metals. Sometimes industrial waste will have heavy metals present in the wastewater, such as chromium, copper, cyanide also will be present in the water. So that is again very much harmful. So we have to remove those toxic metals and its compounds which are present in the water. So we first have to find out how much quantity of toxic metals are present in the water, and based on that we can treat the wastewater, and we can remove those toxic metals present in the water. So in this lecture, basically what we have understood is the wastewater, what is the total quantity of waste, how to estimate it, and what is the design period of wastewater. And also we have seen the characteristics of wastewater, means what are the experiments or what are the parameters you have to find it out. And based on those parameters, basically you have to design the entire wastewater treatment plan. So if some in some wastewater more quantity of chloride is present in the water than in the wastewater treatment plant, so we have to fix it such that chloride content is within the limit. So all the parameters what we have seen till now, it has some acceptable limit. So up to this limit, water the up to when as soon as the water reaches to this acceptable limit, so we will stop our wastewater treatment, and then we'll be disposing the remaining portion into the river stream, or maybe in a dumping ward we'll dump the solid particles. This concludes this lecture. Thank you.